In the past, we would have looked at an equation like x squared plus 6x plus 9 equals 4. We would have subtracted 4 from both sides to end up with an equation equal to 0 that we might try to solve by factoring. In this case, we're going to solve this method in a different way. We're going to go ahead and factor the left side as it is, even leaving the equation equal to 4. When we do that, in this case, we would end up with a binomial times a binomial, put x at the beginning of each one. To multiply to be 9 and add up to 6, you would need 3 and 3. So we have x plus 3 times x plus 3. Since that parentheses is the same, we can write this as x plus 3 squared is equal to 4. The reason why this is helping us is now we can use the square root property to get x by itself. We can take the square root of both sides of this equation. Remember, when you do take the square root of both sides to solve an equation, we need to stick a plus or minus in front of the right side. On the left side, the square root of x plus 3 squared leaves us with x plus 3. On the right side, the square root of 4, we can write this as plus or minus 2. Now, because these are like terms here, the 3 and the 2, to solve this and get x by itself, we'll split it up into two equations. X plus 3 equals 2, x plus 3 equals negative 2. The first one, we subtract 3 from both sides. We end up with x equals negative 1. The next one, we subtract 3 from both sides. We end up with x is equal to negative 5. If you'd like to try a similar process for solving the next problem, pause the video now and resume when you're ready to see the solution. Here we have x squared minus 10x plus 25 is equal to 6. Instead of getting 0 on one side, let's go ahead and factor the left side as it is. Here we would have two binomials starting with x and x. To multiply to be a positive 25 and add up to a negative 10, you would need minus 5 and minus 5. Because this is a parentheses multiplied by itself, we can write this as x minus 5 squared is equal to 6. And now we can use the square root property to get rid of that squared. We'll go ahead and put a plus or minus in front of the right side. On the left, the square and square root cancel out and we just have x minus 5. On the right, we can't really simplify the square root of 6, so we leave this as plus or minus square root of 6. And now we can go ahead and add 5 to both sides. They're not like terms, so splitting it up into two separate equations isn't really going to save us any time. Here we would end up with a positive 5 plus or minus the square root of 6. And now if we wanted to write these individually, we could. We would have 5 minus the square root of 6 and 5 plus the square root of 6.